Hello, my name is Drew. I tutor a number of topics in mathematics here, but today this question that we have is an optimization question problem that's going to be utilizing some calculus here. The question says the medical equipment industry manufactures X-ray machines. The unit cost C depends on the number of machines made. If X machines are made, then the unit cost is given by this function that we have here. And then the question is how many machines must be made to minimize the unit cost? So a good thing to do, a good habit to have, is to try to understand and visualize some of these things. I'm sure you remember probably in your algebra classes and things like that, we learned those graph functions and everything. And sometimes graphing functions, even though there's a very straightforward computational way to answer this question, which we will get to, I feel like sometimes graphing functions and understanding how they look can sometimes help with understanding what you're trying to figure out. So this is a quadratic equation here. So if we were to graph this, for instance, just on some plane here, we notice that the leading coefficient for this x squared term is positive. And x squared, these quadratic equations are always parabolas. And because it's positive, it's going to be a parabola that kind of goes upward, if you will. This number here is 6, 7, 6, 8. Basically means it's kind of up a bit here. So we're going to see something kind of like this. I'm just, drawing something kind of vaguely representative of what we're looking at. And so the question here, how many machines must be made to minimize the unit cost? This y-axis here, this vertical axis here, is that c-axis, or it's the unit cost here. And so to minimize the unit cost, this function line here, this line represents all of the possible costs given some input of x here. And this is the number of machines made. So what we're looking for is the smallest number, which in other words is this little number down here, right? Because it's the lowest on the graph. What we learn from optimization problems in calculus, single variable or any variable calculus, is that we're going to be concerned mostly with how to find this value or how to find this x. And what we notice is that the derivative of a function here is basically going to give us the slope of this function here at any given point. And so here at this point, this is the only place in the function where that derivative or the slope is going to be flat or 0. So our kind of method to go into this is to say, okay, well, I want to find the slope, and then I want to determine for what value of x is that slope 0. So what we do is we take the derivative of the function that we're given. So we're going to do the derivative with respect to x. And then we just use the power rule here for this. So we just take this 2, multiply that, so we get getting 0.4x minus 40. And then this constant term goes away, because the slope doesn't really matter how high or low it is. And then we need to, so this is the slope, and then we need to determine for which value of x is this 0. So we just set this equal to 0. And then we can solve for x in this way. So we add 40 to both sides. We get 40 is equal to 0.4x. Divide both sides by 0.4. And we get that x is equal to 100. In other words, this company has to make 100 machines in order to minimize the unit cost. In other words, this value right here is 100. So if you have any more questions, just let me know. I'm happy to help you, and good luck.